Okay, this is a video to go with the week 5 workshop material that I gave you on how to use Strand 7. It's basically going to be a very quick recap showing you where all the buttons are. If you didn't see the week 5 workshop material, there are a series of other videos on YouTube that I made last year that are very long but fairly comprehensive, which will teach you how to use Strand. This video is meant to be basically just showing you where all the buttons are. So what I want you to do is go through this video with me, pause it every time I press a button, and build the trust along with me to get you some practice. Alright, that's the point. So I've just opened Strand. I'm going to go new. I'm going to work in newtons and millimeters because I find it more convenient. You don't have to. I'm going to start by creating a node at the center of my blank universe, 0, 0, 0. Just a reminder, I am building the trust that you built as your practical competency in this task. Okay. I'm going to make my nodes a little bit bigger so they're easier for you to see, just in case this video isn't coming through at the best resolution. There we go. So that's my first node. We remember that our geometry is going to be made up of nodes connected by beams. So I'm going to make a second node 338 millimeters away, so that we can make a beam to join these two things up. In order to zoom, F3. There we go. Create an element, which is a beam. You don't need anything else, just beam. There we go. Okay, so we make our nodes, and then we create beams that join them up. That's how you're going to make the vast majority of your structure. All right. I could go continuing through creating nodes at all of my other locations, but I can do it quicker by doing tools, copy by increment, this node here, 338 millimeters, 4 times, apply. Again, F3 to zoom. Now I've got all my nodes, create element, join all the dots. I'm then going to grab all of my nodes and copy them up. If I try to do it from here, remember you've got to have this select on. Okay. So grab all of my nodes, tools, copy by increment in the vertical direction, 338, apply, okay. And now I'm going to create my remaining elements. I made too many. Remember, we never want to do this, okay? We never want to join to there. We've got to join all of the bits up. Cool, we have all of our elements. I made one too many by accident. If I go back to select and make sure I'm on beam select, I'll be able to grab that beam, hit delete, it'll go away. So the node, but that's fine. I'm just going to extend this one down using the extrude tool. So extruding works just like copying. Get rid of beam select, so I just grab the node. Works just like copying, except it will make a beam when it does this copy. So it made that beam for me, which was nice. I'm just going to zoom out a touch so I can see what's going on. There we go. Alright, sweet. We've got our structure. Now we need to give these beams, which currently have no material, no properties, some properties. So if I've opened up property, got beam 1 selected, we need to give it a modulus. So again, let's assume it's steel. If you don't know the modulus of your materials, you need to look them up. Okay, that's definitely something you're going to have to search, is both the modulus of the materials you use and their breaking strength. We're not going to put breaking strength in here anywhere, or failure strength. But you need to look it up and you need to know it. Okay. The other thing is, be careful of units. I'm in megapascals. Moduli are generally in gigapascals. So just be careful of your units, particularly if you selected meters. Your units here will be pascals and you'll have a really big number. Alright, so you need a modulus. It's essential. The rest isn't, but you do need a modulus and you do need geometry. Okay, so you can go geometry, edit, pick a cross section, make it 42 by 19, Again, I'm in millimeters. If your units are different, that might cause you problems there as well. I'm going to leave it on beams for now. Remember, beams mean fixed joints everywhere, and trusses mean pin joints, okay? Your truss had pin joints, so that would be a truss that you'd want to select there. I'm going to leave it on beams just because it makes the results a little more interesting. Hit F3, that'll redraw for us. Now we've got our members. If I rotate by hitting F4, or you can press the middle mouse button to open this new window up, and then left click to move around in space. You'll notice our beams are all lying the other way. You can rotate them around by going back into property of your beam is geometry, edit, 19, F3 again, sweet. I want to get square on again, so I'm going to hit F12, XY plane, apply. Awesome. Next thing is to fix this thing in space, so I'm going to put some restraints in. Attribute of a node is a restraint. I'm going to put a pin in on one side and a roller in on the other. So a pin joint doesn't allow any translations, leaves the rotations free. Apply. A roller joint will allow this thing to move in the X direction, so it'll allow it to move horizontally. Apply. If you don't know which ones, you should try a model with both. Okay, if you don't know whether you should be using fixed joints, pin joints, roller joints, just make 10 different models, try them all out, find the worst case scenario. Okay. I just need to put a force on here now, so I'm going to go attributes of a node is a force. Grab that node, put 1,000 newtons on it, apply. Sweet, we've got everything we need now. The fact that I have a node sitting out here in space not connected to anything is fine. It's a node, it has no properties, but if I had a bit of beam out here connected to nothing, that would cause us problems. Just to point out very quickly, yeah, the joints in this model are basically just assumed to be perfect. Strand just goes, yeah, I'm assuming you got your joints right. That's not what we're modeling here. If you want to model joints, you need a more complicated model, which Strand can do, but we're not going to get into. All right, now we want to solve a linear static is what you want to use. Name it something more logical than mesh 19. Solve. No errors, that's good. You can have some warnings. Warnings aren't necessarily a problem, but no errors is important. Close this window, then go results, open results file. There's also a button here that does it, which I sometimes press. Yep, this is our results file. It's the only one we have, so that's fine. Open that. Now we're in our results window, which looks very similar, but we get some extra options. Generally, the first thing I always do is put a displacement scale on, so it's that one. 10% is generally a good value, and it will make everything deform. Now, this is an over-exaggeration. It's not how far this thing actually moved, it just shows you visually how it moved, which means you can look at this and go, yeah, that's more or less what I expected it to do. I probably haven't made any massive mistakes. The more useful thing is result settings, contour, stress. Okay. I'm going to do displacement first, just to illustrate the point about the displacement scale. Let's say deflection D in the X, Y, and Z combined. So total distance any of these things moved was 0.017 of a millimeter. Okay, that's the furthest any point on our structure moved. Less than, well, just over 100th of a millimeter. So this displacement scale is an over-exaggeration, but it just shows you what's going on. Displacements of stress. Total fiber is what you want. Okay, just always pick total fiber for everything you're going to do. Cool. Now we can see our stresses in our structure. We can see that these members are in bending and they have got some extra stress down the bottom there. And the maximum stress in our structure, 2.1 megapascals of tension, and in compression, 1.48 megapascals of compression, just off the top. This is where I said it's important to have looked up and know your failure strength of your material, because steels are at least 100 times that. And basically then from this stage, have a bit of time, look at your results, think for a little while. If you sit here and you think about this, hopefully you will be able to realize that, okay, the weakest point of my structure are these parts here, and that's because they're in bending. If I had a pin jointed structure, we wouldn't have any bending, and these things would get stronger, so you could go back and turn this into a truss. The other thing you can do is look at these members here and go, wow, they've got basically zero stress in them. I can probably delete those members and I won't lose any strength. And then basically do that over and over and over again until you have an optimum design. Okay? I would expect you to be doing hundreds and hundreds of solves amongst your team before you get something that you're happy with. Just try all your ideas. Just want to check that I've covered everything that I wanted to cover, more or less. The only thing that I'm going to do right at the end of this video is just recap hotkeys that are important. Okay, so to create a node, Control W creates a node, and then you can just enter your XYZ coordinates. To create an element, Control E, and then you can join your things up. Control Z does work as an undo. F6 is to zoom in. You just draw a box to zoom. F3 puts everything in your universe centered in the middle of your screen. F4 for rotations, and then that's a left click to rotate and a right click and move your mouse to zoom. It's weird, it's not nice, but you get used to it pretty quickly. F12 brings your view window up and you can go back to X12 plane. They're the ones I use the most. The only other things are Control F is a find option, so if you want to find node 10 or 8 for some reason, you can do that. If you hold down Shift and you hover over things like nodes, it tells you some information about them. So that's telling me it's the XYZ coordinates of the node. Can be really useful for checking things. If you go to beams and you hover over them holding Shift, it will tell you their length. So 478 millimeters, which is a kind of cool feature. Other than that, I think I'm done. So basically, watch this video, build the truss, have a crack at building the tower. As you have questions, ask me or your workshop leader. Okay? Good. Good luck.